All right, folks, so we're going to go ahead and get started with this, a little bit of reviewing of the stuff we did. We're going to look at the homework, and we've pretty much finished all the basic topics in indefinite integrals that we're going to cover. And so that means to me that we're ready to have ourselves a little bit of a quest. So today's objectives, again, I'm still working on finding indefinite integrals for all different types of stuff. But I'm going to announce that on Tuesday next week, you guys are going to have a quest. It's a little bit bigger than a quiz, smaller than a test. On indefinite integrals and all the stuff we've learned since I took over. Today we'll review, tomorrow we'll review, okay, and then if you're here on Friday, you can take the quest then. If you're going on JSA, then you can wait all the way until Tuesday. And I understand that JSA won't be here for the whole weekend, but you'll have Monday night to do some studying, so you're going to have to do it then if you can't find some time over the time while you're at JSA. Okay, so here's what we're going to do quickly. I'm just going to go through all of the homework problems. If you think you're just a baller and you don't need to focus on any one of the problems, then go ahead and skip it. But I think it's important to listen to me walk through some of these and listen to some of the stuff that you have to say and make sure that you're doing these problems correctly. So I would watch them all unless you're sure that you've got this. And then Mr. Jones is going to have a big packet of problems for you guys to work on, and then as practice for this, start reviewing for this quest, and for you guys to finish as homework for tomorrow. So let's start by reviewing the homework. Let's start with this first one. It's the integral of 6 times the quantity 2x plus 4 squared dx. Okay, we're going to use our u substitution, and to me it's pretty obvious that this 2x plus 4 is on the inside, so I set that equal to u, and then I differentiate. The derivative du dx is just 2, because the derivative of 2x is 2, and the derivative of 4 is 0. Now I rearrange, throw that 2 in the bottom, throw the dx on the side. And now I come back over here, I replace the inside function with u, I replace the dx with du over 2 like so. That 6 and that 2 cancel out to give me a 3. And of course, the integral of 3u squared is just u cubed plus c. The last step is to replace that u with what it is originally, since u is just made up, and that gives me 2x plus 4 cubed plus c. Next. So it's a little bit trickier. Here we have 1 over negative 4x plus 9. Of course, we can't separate this into different functions because we have this plus in the denominator. So I'm thinking that negative 4x plus 9 could be the inside function here. So I'll try that. And if it doesn't work out, then it's okay. I'll just start over. So u is negative 4x plus 9. I can take its derivative. That's negative 4 because the derivative of negative 4x is negative 4. The derivative of 9 is 0. Rearrange, put that negative 4 in the bottom and the dx on the side. Now we come back to the integral, replace the inside function with u, and replace dx with what we just found. Okay, I'm going to pull out this negative 4 to the out front. Now I got my negative 1/4 out there, and my 1 over u. Now this is a lot of people struggled with this one. Well, now what? Should I rewrite it as u to the negative 1 and so on? Well, if you have your functions memorized from your memorization quiz, then you should know that the integral of 1 over u is ln u. Okay, and then I just throw my negative 1/4 in there, and I plug my u back inside the ln to give me a final answer of negative 1/4 ln of negative 4x plus 9 plus c. All right, you may be upset with me because it turns out this fourth one is not possible. The integral of sine of x cubed has some kind of answer, but there's no way for you guys to do this one without another tool that I haven't taught you yet instead of u substitution. So I'm sorry for putting that on there. It was a mistake. Next, this one very similar to the one we just did a second ago, except now we have, instead of just a function in the denominator, we have the square root of something in the denominator. Okay, I saw some people try and take this problem on by setting u equal to the square root of 7x plus 5. You could try that, but you're going to end up not being able to cancel out all of your x's, and then you'll be in a bad place. And if that happens, it's okay, just restart and choose something else for u. For me, I see the 7x plus 5 as the inside function, so I set that equal to u. I take its derivative, which is 7, and rearrange, putting the 7 in the bottom. Okay, now I can replace the dx with du over 7, and I have my 1 over square root u, because I replaced the 7x plus 5 with the u. I'll pull that 1/7 out, and of course I can rewrite this, right? I have square root of u, well that's the same as u to the 1/2, and it's in the denominator, so it's u to the negative 1/2. Negative 1/2 plus 1 is positive 1/2, right? And then I just divide by positive 1/2, which is the same as multiplying by 2 over 1, or just 2. And that gives me 2/7 u to the 1/2, or 2/7 square roots of u. Replace the u with 7x plus 5, and you're all done. All right, last one, tricky one. we have that the integral of tan x, okay, and I'm going to change that over to be the integral of sine x plus over cosine x, okay, because that's what tan is equal to. Okay. Now, a lot of students said, "Well, hey, which one is u now? It can't just be x. There's no point in replacing x with u because that's just changing the name of the variable. That doesn't make a difference." I think you can actually choose either one. I think you can choose either. Well, maybe not. I'm going to choose cosine. I challenge you to try this with sine. It might be possible. But I'm going to choose cosine. And if you chose sine and it didn't work out, then of course you just restart and try something else. Okay, so here we have u as cosine. You take its derivative. The derivative of cosine, we go back to our rules about the co, we add a negative to that sign. Then we switch them up, so we put the negative sign in the bottom. Okay, then we come back to our function. We replace the cosine with u. We replace the dx with du over negative sine x. Okay, my signs will cancel, and I'll be left with that negative out front. And don't forget that sometimes on the AP exam, they might take this du and throw it in there where the 1 is, make it look like that just to be confusing, but those are the same thing. Okay? Now, what's the integral of 1 over u? We know it's ln u. Okay, and my negative chills out front. Don't forget about the plus c. And then we replace the u with cosine x to give us our answer. Now, that looks really weird, right? You wouldn't think that that's the integral of tan of something. But if you do it out by taking the derivative of what you see here, you'll find that you'll end up with sine over cosine, which is the same as tan. Okay, there are two other problems that were assigned, and these ones combine the u substitution skill with an additional step of going about solving for c using an initial value. I want to note that I did make one mistake. I've changed it in this example. I did write f prime of x is equal to the integral of some function. I meant to say regular f of x, right? Once you integrate, you go from f prime to the regular one, and you're given a fact about an initial value for the function, so we must be looking for that function to use this initial value. But anyway, we got the integral of cosine of root x divided by root x dx, okay? So I'm guessing the inside function here is root x because it's inside the cosine. So let's go ahead. U is root x. Take its derivative. This is a factor worth memorizing. The derivative of square root of x is 1 over 2 root x. Just memorize it. Just memorize it, okay? Now this one's a little bit tricky. When we solve for dx, we want to get the dx by itself. We can kind of cross multiply. Bring the dx up and bring the 2 square roots of x up on the other side. And that gives me 2 square roots of x du equals dx. So this is probably the first time where we've seen it where the dx, there's nothing in the denominator over here, right? This ends up in the numerator. Okay, we come back. We replace the root x with u. And we replace the dx with, oh, I made a mistake. This should say 2 square roots of x du, not dx. Okay? The root x's will cancel. Now I'm left with my, and again, that should say du. That's a big mistake, Mr. Caden. I bring the 2 out front. My root x's have canceled. And it should say integral of cosine u du. That's a mistake. And of course, the integral of cosine is sine. And we replace the u with root x to give us our final answer. Except, we're not quite done, because we have this initial value. F of 0 is equal to 3. So if I plug in 0 for x, this whole thing should equal 3. So I can do that. I'll put 0 in, and I'll put the 3 out here. Of course, the square root of 0 is 0, and the sine of 0 is also 0, and 2 times 0 is also 0. So this whole thing is 0, and that means that c is equal to 3. Giving us a final answer of f of x is equal to 2 sine of square root of x plus 3. Last one. This one was the hardest one, I think, although it was pretty obvious that 2x squared plus 7 is inside some other function with the cube, so that's definitely our u. We take its derivative. Du dx is 4x. Okay, and now we have this x chilling out here. It's really important that when we go back and plug stuff in, that we eliminate all of the x's and are left with just u's. Let's make sure that happens. We flip this around, put the 4x in the bottom, put the dx on the side. Now we take it and plug everything back in. We take this 2x squared plus 7 and replace it with the u, and we plug back in for this dx like that. Okay, and you can see I've got the u cubed down here, I've got my 8x left on top, and I've got this 4x on the bottom, and lucky us, these x's are going to disappear, and the 8 and the 4 will also cancel out to give us a 2. And of course we can bring that 2 out front, which might be nice, and I also move this du up front just to be confusing like the AP exam might do. And again, we could rewrite this, because we have u cubed in the denominator, as u to the negative 3 du. To integrate this, we add 1 to negative 3, which gives us negative 2, and we divide by that negative 2 over here. The 2's cancel, and that gives us negative u to the negative 2, or negative 1 over u squared. There should be a plus c there, and there isn't. There should be a plus c right there. I'm a terrible mathematician. Okay, then I go ahead and plug back in for u. I got the 2x squared plus 7 back in there now. And I'm almost done, except that we have, again, this initial value, which will help us to calculate what c is. I plug in 0 for x, and I plug in 2/7 for f of x, because when f of 0 is 2/7. So we get that. If I plug in a 0 for x, this all disappears, and we're left with just the 7 down there. 7 squared is 49. Okay, so now I have this, and I'm going to convert this into 49ths. Okay, all right, fraction masters. I can multiply the top and bottom by 7 to get 49ths down here and 14 up there. I add this over to the other side to get c is 15 49ths. Meaning the final answer is -1 over 2x squared plus 7 squared plus 15 49ths. If you got a little confused on the fractions and stuff, that's fine. If you understand the big concepts, make sure that you can go through these problems and all the steps. Otherwise, you shouldn't worry.